A microcontroller is a compact, single-chip computer that integrates a processor, memory, and input-output I/O peripherals. Microcontrollers are designed to perform specific tasks and play a crucial role in electronics. Microcontrollers can be found in a wide range of applications, including automotive, home appliances, industrial automation, consumer electronics, such as cell phones, laptops, gaming consoles, and in medical devices. Overview of the PIC family. The PIC, Peripheral Interface Controller, family is a well-known group of microcontrollers that are used in many different types of electronic devices and systems. And the PIC16F877A is a popular model with lots of built-in features that make it useful for many projects. Micro-C is a software tool that lets you program PIC microcontrollers using the C programming language, which makes it easier and more convenient to create electronic projects with these microcontrollers. We are going to use ProChews software to design and program our microcontroller and simulate in real time. You can follow me as I designed this schematic on ProChews. So we are going to program our microcontroller using Micro-C Pro for PIC compiler. So we are going to first create a new project. So we are going to name our project Blink LED. Since we want to blink a LED, let us choose a folder where we are going to save our project. Select the PIC16F877A and a clock frequency of 8 MHz. So we click on Next. So here we can start our programming. This is the main function where our entire code is going to be written. So I am going to define the state of the pins. So I want all the pins at PORTB to be output since we have connected our light emitting diode on pin B7. Now let us write the code to blink our light emitting diode. So the code is going to run in an infinite while loop. Port B equals 0xFF means all the values on port B should be set to 1. The light emitting diode should turn on. Delay milliseconds 1000 means it should delay for a period of 1000 milliseconds, which is equivalent to 1 second. Port B equals 0x00 means you set all values on port B to 0, meaning the light emitting diode should turn OFF. So that is all about our code. Now let us run it and load it into the microcontroller for our simulation. We will look for the hex file and load it to the microcontroller. So we have to change the clock frequency of the microcontroller to 8 MHz as per the frequency defined in microC. Now let's run the simulation. As you can see, the light emitting diode can't turn on because of the high resistance value of 10 kilo ohm connected. So let's reduce this value to 220 ohm. And run the simulation again. As you can see, the light emitting diode turns on at intervals of 1 second as per the code. Now let us update the code to turn on the light emitting diode to 5 seconds and observe. As you can see, the light emitting diode switches on for 5 seconds and then goes off for 1 second. You can modify the code to suit your needs. Equally, by doing so, instead of connecting a light emitting diode to the circuit, you may connect a motor, relay, or any other device you may want to control using the microcontroller. Thank you for watching, and please don't forget to subscribe.